What is time? This is probably one of the most difficult questions you can ever ask a physicist or philosopher. I'm not a physicist, yet, nor a philosopher, but here I am, little old me, not only wondering about the nature of time, but also making a first ever YouTube video about it. My aim is to make you think, to create discussion, and of course, I hope you enjoy the video. The answer to what time is may be as simple as, time is what the ticks of a clock measure, or time is what keeps everything from happening all at once. But let's dig a bit deeper than this and make this video a bit more fun. Let's start with Newtonian time. Newton's view of reality implied that time was external and absolute. Newton's time is a kind of container, where events take place in a completely deterministic way, linearly and independently of the observer. Then came Einstein. His theory of special relativity and then general relativity both led to the conclusion that time is relative to the observer. Time depends on where you are and how you move relative to others. There is no such thing as universal time. Space and time are constrained by c, the velocity of light, in such a way that the now of one observer is not the same as the now of another observer. Mass equally can also distort space and time. Time dilation and length contraction are not just theoretical constructs within an elegant theory. These effects have been tested again and again without failure. At macroscopic scales, Einstein's theory has been shown to be a very good model of reality. Let's talk about time dilation with an example. We have the elementary particles called muons, which have a half-life of around 1.5 microseconds. That means that if we have, say, 100 muons in the lab, after 1.5 microseconds has elapsed, we will have, on average, 50 muons left. The other 50 will have disintegrated. After another 1.5 microsecond, we will have, on average, 25 muons left, and so on. These particles are produced at the edge of our atmosphere due to incoming cosmic rays hitting air molecules. They are constantly produced, so there is a constant fall of muons towards the Earth's surface, traveling at nearly the speed of light. What is observed experimentally is that more muons are detected than one would have expected when we consider their average lifetime. This fact can only be accounted for when we use the model of time and space given by Einstein's special relativity theory, where time and space are constrained by c, the velocity of light, and so times and positions are relative to the observer. In this case, from our point of view, the muons' own time appears dilated. More of them can reach the Earth's surface from our perspective because a second of their time lasts longer than a second of our time. So we see that from the very beginning of last century, the concept of absolute time was shattered, and time was understood as being completely dependent on the observer. Newton's absolute time is only a good approximation when speeds are low and when we can effectively neglect the effects of nearby masses. Now, let's take a look at the concept of time from a philosophical point of view. We have what is called the A theory of time and the B theory of time. These were introduced by the philosopher John McTaggart at the beginning of last century as well. The A theory of time says that the only real time is the present. The past is gone and the future exists as just a probability distribution, a potentiality of possible things that can happen. There is no set future on a kind of imaginary line laid out there for us just waiting to happen. Therefore, the future is not real. On the other hand, the B theory of time says that past, present and future all coexist and are as real as each other. The B theory says that the distinction between past, present and future are just an illusion of consciousness. One of the consequences drawn by many orthodox physicists as a result of either Newtonian physics or relativity theory is that determinism is a fact, that the past completely determines the future, and hence all what has happened since, say, the Big Bang was determined by the initial conditions, including you and me and our actions, thoughts and feelings. There is no room for free will, which is seen as just an illusion when we take this deterministic point of view. Hence, it seems that it is the B theory of time, not A, the model of time that most closely agrees with the classical equations of physics. So, It appears that common sense agrees with A theory, but classical physics agrees with B theory. Could it be that time is a bit more complicated than what A or B theories of time suggest? That reality is a mixture of the two ideas? Could it be that a linear model of time is not a good approximation of reality? We will explore this issue in a bit when we talk about quantum physics. Now, before going into quantum physics, let's take a little break. How do I personally think of time? What is my own experience of time? On a personal level, I intuitively feel that time is not some mysterious external dimension or construct that flows in the forward direction, that kind of dictates in what order events can happen. But I feel that it is rather a much more fundamental concept, even more so than space. I see time as a concept that is intricately linked to the individual's perception of change. I think of time as the perception of duration, of change, and the ordering of events by a living entity, or in fact you could say by a conscious entity. Here I'm defining consciousness in line with awareness, hence animals and primitive organisms would have their own concept of time, depending on how they perceive change. On the other hand, I do not see time as a strict illusion either, nor as a block of events completely determined beforehand. I see it as a pliable tool which, when used within this particular universe we live in, it enables our experience of 3D space and the perception of the ordering of events. In that way, I often ask myself that, if time can be thought of as a perception of change, what happens when there is no change and no perception? Imagine you are somehow still conscious, but confined in a universe where nothing ever happens, and you have no perception of any change whatsoever occurring. This reality would obviously be nothing like our physical universe. What are you left with? The first thing that comes to mind is that time does not make sense in such a universe. It does not exist, unless change can be perceived by some sort of being, or beings that populate it, so that some order can be assigned as to what goes first, what goes after, and so on. Maybe time could be thought of as a perpetual now under those conditions. And all thoughts obviously bring up the idea of universal versus relative, or we could say individual time. However, here we're talking about ideas that are well beyond Einstein relativity theory. We're not talking about time and space in our physical universe obeying certain rules whereby c, the velocity of light, and mass restrict how space-time behave. But in addition to this, we're talking about time being something that is meaningless in the absence of an entity, a being, or a consciousness and awareness, who is able to perceive change, therefore being able to assign a before and an after to events that occur. The idea that I often wonder about, and that I feel is very important too, is, are space and time fundamental? If so, are they equally fundamental? Could it be that one is more fundamental than the other? I intuitively see time as more fundamental than space. I can sort of picture a reality, a state, let's say a state outside of this universe, where space does not exist, but time does. Where only patterns of states exist and there is a chronological order that can be perceived between them. This is analogous to, say, my thought space, when I meditate, for instance, and reach certain states where there is no feeling or perception of space, but there is definitely a perception or distinction between different states and a perception of which one preceded which. Time can be thought of as a fundamental structure that allows perception of order between changing states or patterns, that is, order as in before and after. A property can then be added so that there isn't just order between states, but there is also a rule that regulates the basic fundamental tick between events, beyond which change cannot be perceived. In our physical universe, this fundamental duration could be the Planck time. I will expand on the concept of the Planck units in other videos. On the other hand, I cannot imagine the perception of a 3D physical space existing independently without time. The way we perceive physical space is dependent on the time it takes for light to reach our eyes. If we talk about non-visual perception, all other types of physical senses are constrained by the velocity at which information within space can be transferred physically to our senses. So, any successful perception of 3D physical space is tied to the existence of time. This is, of course, my own interpretation of time. But what does current science have to say about this? Well, recent research carried out by a particular quantum gravity research team involving quantum universe simulations seemed to indicate that time is fundamental, not emergent, that it existed before space, and not only that, but their theory says that time has no beginning nor has it got an end. For references, please see the video links at the description section, in particular the talks by Renata Law, a professor of theoretical physics. Computer simulations get better and better with time. It will be fascinating to see what kind of universes can be created and what we can learn about the nature of our reality. All these concepts are inevitably linked to the debate of whether the world exists out there, independently, without needing aware or conscious entities to perceive it. It seems that my particular interpretation of time, as I have discussed so far, does not make sense unless some sort of consciousness is involved, be it a consciousness perceiving our universe from within it or from outside of it. So, is there an objective reality out there when there is no conscious beings to perceive it? This is a fascinating subject that quantum mechanics brought to the surface within the context of science at the beginning of last century. A subject which was by no means new and which many religions and philosophers had already debated for thousands of years. But the fact that this can now be studied within physics is very, very exciting. When it comes to consciousness, unfortunately, many physicists cringe when they hear this word. However, this debate was not started as a kind of New Age idea, but rather it started within the context of experimental science, for example when discussing the possible interpretations of the double-slit experiments results. It seems to me that it is partly due to some New Age ideas that flourished later on, which used quantum mechanics as a kind of platform to support their theories about reality, that today many scientists feel uncomfortable when having to consider consciousness as having a fundamental role in the way the physical universe works. Let me clarify, this is independently of the validity of these New Age ideas. I personally have no problem with any kind of ideas, as I try not to have any prejudices or preconceptions. The important thing to remember is that these ideas were initially brought to the surface by many of the eminent scientists who were at the forefront of quantum mechanics at the time. Einstein, Bohr, Schrödinger, Heisenberg, Wigner, Bohm, Wheeler, the list goes on. These are not New Age quarks, a word that the skeptics seem to overuse these days in my opinion, but very brilliant minds who laid the foundations of quantum mechanics. Most of these scientists didn't just shut up and calculate, very famous quote by Feynman, but they discussed the philosophical, metaphysical and physical interpretations of quantum mechanics. Consciousness or mind, the existence of objective reality, the illusion of time. These were not New Age ideas, but very important ideas about reality that originally came from the bunch of brilliant scientists who created quantum theory. I find it very unfortunate that many mainstream scientists today seem to want to distance themselves from any discussions involving consciousness, because they associate it with New Age, spiritual or religious ideas of the universe. There are too many links with Eastern philosophy or religion for their taste. Not to mention the incredible difficulty of introducing something as immaterial as consciousness into a purely materialistic view of the universe. I find this quite sad, because when science finds something that challenges the current paradigm, and there is enough evidence, in my opinion, that maybe we're actually missing a very important part of the equation, we should strive to think outside the box to explain it, rather than trying to make it fit into our existing materialistic view of the universe. Okay, so let's go back to the concept of time and explore how it can be perceived from the point of view of quantum physics. I will try to be brief here, as I will make plenty more videos on quantum physics in the future, including all its different interpretations. Quantum physics provides a view of the microscopic world which is based on probability distributions. Particles do not seem to be actual physical particles as we think of them, unless they are observed. In the meantime, they seem to exist in some sort of probability realm, in a superposition of states that obeys a particular wave equation, that is Schrödinger's equation. When a measurement is made, meaning that information is made available and retrieved in the macroscopic reality regarding some property of the particle, then the wave function is said to collapse. The otherwise deterministic probability wave suddenly jumps from a superposition of possible states to just one. It seems that the observer has a very fundamental role in the now moment when reality is observed, when a measurement is taken. So reality appears to be a deterministic flow in probability space until, voila, somebody decides to look. And one particular state is picked from this probability cloud, seemingly randomly, and then reality takes a definite form. Both the now moment in time and the observer seem to be crucial in the description of reality. Now, let's talk briefly about the arrow of time, entropy, and the deterministic equations of physics. Okay, so it is a fact that within our physical universe, we observe the arrow of time to point in the direction of increasing entropy, increasing disorder. Quality is preserved, yet it does not seem to appear as a fundamental thing within our equations. The arrow of time is not found within the fundamental equations of classical physics. There is nothing in these equations that says that now is different from 2 hours ago, or 4 hours into the future, or that past should precede the present for that matter. On the other hand, the statistical second law of thermodynamics shows that the arrow of time points in the direction of increasing disorder, and this emerges from the study of macroscopic systems. On the other hand, I find the work of Renata Lal and her team very interesting in this respect. Their work points in the direction of a very fundamental role for the arrow of time in universes like ours, when we look at the problem from the perspective of a microscopic universe using quantum gravity, studying space-time at the Planck scales, using simulations. But let's rewind a little bit now in order to compare the classical perspective with the probabilistic perspective. The classical equations of physics do not differentiate between now and before or after. There is also no possibility for free will in the deterministic equations of physics. In fact, now only takes center stage from the point of view of an observer who can be aware, possibly with free will, that experiences only the now moment, who can somehow influence reality by the very act of observing. So, I can't help but conclude that no wonder the classical equations of physics cannot explain the importance of the now instant of time. The observer and the effect it has on reality has no place at all in classical physics. In fact, even the Schrödinger equation in quantum physics is inherently deterministic until observation, measurement takes place, precisely at the now moment, the present, and it is precisely then, as if by magic, that collapse takes place and determinism ceases to exist. The collapse of the wave function, the collapse of determinism, takes place at the precise now moment when knowledge or information about the system is retrieved in this reality in a macroscopic way. An observation takes place. So a way to look at this is to see the deterministic part of quantum mechanics, Schrödinger's equation, as a model that describes what goes on in the background, that is outside our space-time, in a probabilistic realm, when we're not actively retrieving information from there into our space-time. The now moment is also crucial because it is the moment when a conscious observer's free will can actually operate, if we assume consciousness and free will not to be an illusion, but a real entity that is fundamental in the way we describe our reality. It is not the case, in my opinion, that we are forced to go from a deterministic view of the universe to one based on a mixture of determinism and pure randomness, as some physicists and philosophers seem to extrapolate from quantum mechanics. It is true that simple double-slit experiments do not explicitly show conclusive evidence of an interaction between consciousness, including free will, and the quantum realm. They can be interpreted in different ways, for instance using just explanations which regard information or knowledge as the key factor. However, there are numerous other experiments that not only show that things are actually a little bit more complicated than what I have described so far, but that consciousness and free will can indeed influence the outcome of a quantum experiment by having the power to alter the probability distribution that describes the system in between definite physical states. In this way, what would be an otherwise deterministic Schrödinger equation, which is the probability cloud going on in the background, can be affected by consciousness and intent. There are several experiments that provide evidence for this fact, including those that involve quantum random number generators, for instance, those performed by German physicist Helmut Schmidt. Experiments such as these are the ones that provide conclusive evidence that our world is neither deterministic nor completely random, and that consciousness and free will play a central role. I will talk about these experiments extensively in other future videos. I would like to stress something that I feel is quite important here. This is not a video where I discuss the existence of free will. This is a very old debate which turns out to be mostly based on assumptions related to where consciousness originates from, and this includes our decisions, choices. It is also usually based on whether consciousness is an illusion or not, on whether consciousness is just a result of purely physical interactions, and often on the assumptions that linear physical causality can provide the answer to all events, including our decisions. The problem sometimes is simply that people don't even agree on the definition of free will. Most consciousness and free will debates these days become a battle of egos, to see who comes up with the cleverest logical argument. Those who deny the existence of free will tend to use quite a few flawed assumptions, in my opinion, completely ignore personal subjective experience and common sense, as well as all the relevant experimental evidence that is already out there. And no, the evidence does not come from logic land, nor the belief in purely linear physical causality, and it doesn't come from your typical quantum physics book either, nor from the study of neurophysiology. Back to the topic of time, I am simply stating that, considering the central role that the observer plays when we look at the universe from the quantum physics perspective, we can conclude that the present, the now moment in time, is precisely when the universe can arise from the probability realm, as a consequence of our observation, non-deterministically, and equally importantly, it is also the moment when our free will can operate, assuming it exists. From this perspective, the 3D universe we experience and the passage of time we experience are not only relative to the observer, but cannot be considered as separate entities independently of the observer, their consciousness and their free will. The concept of a probability realm computing outside of our space-time, the concepts of entanglement, of non-locality, all these are ideas that make me wonder if this other realm out there also operates within time, and if so, if we would be talking about a time frame that is a larger subset than ours, while including our own. So in this way, at the Planck scale of time, below which we can't detect any more physical change, not even in principle, we would still have the other realm, where a lot of stuff would be going on in the background. Whether we call this non-local realm another dimension, reality, universe, or whether we consider it part of our universe, is just a semantics issue really. The fact is, this realm is intimately linked to ours. This idea is in fact analogous to that of nested time. This is the concept of generating nested realities, each new reality having a fundamental time duration, analogous to our Planck time, which is equal or larger than fundamental time duration belonging to the reality it has been created from. This fascinating idea that, along with many others, was introduced to me by Tom Campbell, a physicist and consciousness explorer to whom I will be forever grateful for opening my mind and helping me get rid of dogmatic beliefs. And I am not talking about religious beliefs here, but beliefs within the context of science. I would like to finish this video with another fascinating topic. I will present it with this question: can the present change the past? Can our choice of what we do now affect the outcome of what we perceive to be in our past line of causal events? Well, it turns out that certain double-slit type experiments in quantum mechanics seem to provide evidence of backwards causality in time. For instance, the delayed choice quantum eraser. Well, I won't go into all the details of the experiment here. The idea is that my choice of how to observe reality now appears to change the events in a particular part of the quantum system, events which could only have occurred in the past. I will outline the basic ideas that we're dealing with here, and why the way we interpret our reality makes a huge difference when it comes to resolving issues such as that of apparent backwards causality. This in turn will influence how we interpret the nature of time and the arrow of time. It all boils down to this. If we think of reality as a physical objective reality existing out there, independently of us, where events that were not observed in a macroscopic way still did happen, really, physically, in our space-time, then we have to accept backwards causality as a fact. On the other hand, if we think of reality as a construct linked to observation, with a probability realm operating in the background, whereby information is not really physically in our space-time unless we retrieve it in a macroscopic way at the now moment in time, then turns out that backwards causality is just an illusion and can easily be explained rationally. In other words, if reality is not objective, events that we consider to be in the past timeline corresponding to a certain part of a quantum system whose information has never actually been retrieved in this reality, that remains in probability space. That is, nothing really happened in a past objective physical reality, which was consequently changed at the posterior moment, whereby the present changed the past, violating causality in time. When nobody has ever retrieved the information, or when we erased any possible existent information which would otherwise have enabled an actual observation within our own space-time, then things remain in the probability realm. Nothing physical ever happened in our past. It all remained in probability space outside of our space-time. So what we eventually observe, when we finally decide to retrieve information in a macroscopic way, cannot be causally associated to another assumed event that we have, erroneously, tracked back linearly in time as if it had occurred within our space-time earlier on, when in fact it didn't. It remained a probability cloud, because it was never observed in the first place. I know this may sound very confusing now, but I will make other videos in the future where I discuss this in more detail, as well as other quantum mechanics issues, such as non-locality and entanglement. The important thing to remember here is that a linear arrow of time, viewed from the deterministic point of view of an objective reality, doesn't make much sense, particularly when we deal with quantum systems. However, this does not imply that causality within our physical spacetime is violated. On the contrary, when we do observe both the cause and the effect at the time they happen, by observing I mean we retrieve information macroscopically, then causality is always preserved. When parts of a system remain unobserved at certain times, as it would be the case in the context of a quantum system, then the illusion of retrocausality, or in more general terms, the illusion of a violation of linear physical causality, arises. What we think of as time in our physical universe is, the way I see it, defined by the perception of the now moment, the present, by a conscious, free-willed entity who actualizes probability space. It brings information into their own space-time reality by the act of observation. In addition, the concept of the existence of an information flow between our reality and the probability realm lying behind it is what can help us expand the idea of causality and the idea of the arrow of time, by understanding that unactualized events, that is, hypothesized and observed events within our reality, cannot be fit into a linear description of a causal chain of events. As Tom Campbell describes it, past and future can be thought to exist simultaneously, but not within the context of a deterministic physical reality, a linear space-time, but as multiple branching timelines of events existing within probability space, in a sort of database, constantly being actualized outside our space-time. The past database is made of the information describing all actualized events, what did happen, that is, what was observed, experienced, as well as all the information related to events that did not happen, and their corresponding probabilities that they could have happened. Similarly, the future database includes all the events that can happen and the probabilities that they might happen. The main ingredient that makes this a non-deterministic reality is the presence of conscious entities, aware entities, in all shapes and forms, which can navigate this branching probability maze by using their free will, the ability to choose among a set of perceived options at the present moment in time. I find this way of describing reality absolutely fascinating, and we're not talking just about quantum systems here, but about the whole of our reality being probabilistic in nature, with consciousness or information being fundamental in its description. Let's not forget that physics was originally a very clear set of metaphysics and philosophy until materialism took over. If it is indeed the case that our space-time is constantly trading information with a dimension or realm which is outside of it, we will need to reconsider our scientific method, how we define science and what its limitations are. Well, we have reached the end of the video. I hope that you have enjoyed it. Don't forget to give it a thumbs up, comment and share if you have liked it. If you disagree with any or all what has been said, please post as well and let's discuss. And please be always respectful to others. I do not appreciate rude, angry, disrespectful or non-constructive comments. Have a lovely day and see you in the next video.